In this video, what we learn is the segment of a circle and its area. So now, what is a segment of a circle? Well, just saying a segment in a circle is nothing but, it's the region that is enclosed by an arc and a chord. We've got an arc here, PRQ, and then we've got a chord here. So this is the area enclosed by this chord and this arc PRQ. So this part is the segment of the of a circle. If you take this entire triangle and this arc, then it becomes a sector, and you know how to find its area and all these things. But this is the segment, right? So there's a different formula to find its area. It's just nothing but the area of the sector minus the area of the triangle. That's all. So let's come to it. So let me give you the actual definition of the segment of a circle, and because of that we also come into something called as the major segment and the minor segment. Well, major segment is nothing but the segment corresponding to the major arc of a circle. This is the major arc of a circle. The minor segment is nothing but if the boundary of a segment is a minor arc of a circle. See, if this is the segment and if the boundary of it is a minor arc of the circle, then the corresponding segment is called as the minor segment. So, this is the minor segment, and then, this entire thing is the major segment. That's what it is. PRQ is the minor segment, and PQSP, this entire thing apart from this blue thing is the major segment, right? So that is what it is. All right, let me give you the definitions of everything. So here we've got the definition for the segment of a circle, which reads like this: the region enclosed by an arc, this arc PRQ, and a chord, this chord PQ, is called the segment of the circle. All right. So since this is enclosed by the minor arc of the circle, it's called a minor segment. And if the same thing, if this is enclosed, if this chord is enclosed by a major arc, then this is going to be called as the major segment. So now let's go to the minor segment definition. All right, so here we've got the minor segment. Minor segment, if the boundary of a segment is a minor arc of a circle. So, this segment here, PRQ, the boundary of it is, the minor arc. So therefore it's called the minor segment. So now let's get into the major segment. So here we've got major segment. A segment corresponding a major arc of a circle is known as a major segment. Where if this chord PQ is enclosed by this PSQ arc, which is the major arc of the circle that we're talking here, then this PSQ becomes the major segment. That's all that is. So now all that we're left with is the area of a segment. How do you find the area of a segment? Well, you need a formula to substitute things, and let me give you that formula. It's very simple. You just need the area of a sector from which you subtract the area of this triangle, for which we've got a formula. Now, say for example, this triangle is divided like this, and if this circle was a theta, this angle was theta, this would be theta by 2, this would be theta by 2, right? So yeah, and let this point be L. All right. So keeping that in mind, we are going to find the area of the triangle in a trigonometric way. So now let us look into the area of the segment of a circle. So here we have the area of the segment. As you can see, this part, this one, theta pi r square by 360 degrees, is the area of the entire sector here. That is POQ and this entire thing. So you need to subtract the area of this triangle from that. So the area of the triangle with respect to the data that we've got, the area of the triangle can be found in various ways, but then those are depending on the data that you've got. But here we've got only theta by 2. So with respect to this, we need to use this data. We've got theta by 2 and we've got the radius of the circle. So we've got to use this formula for the area of this triangle. Subtract the area of this triangle from the entire area of the sector, and then what you get is the area of the sector here. The ones that I've shaded in the green, right? So that is all that there is. Although you can write this, you can see that there are two terms here and r square is the same in both. So take out r square as common, and then you've got theta pi over 360 degrees minus sine theta by 2 cos theta by 2. So this sounds or appears a little simpler than this. Anyways, it doesn't make a difference as long as you can understand how the area of this segment is come. It's fine. This video concludes the basics and all the information that is required about the segment of a circle. So in the forthcoming videos, let us solve problems based on segment of a circle and its area, of course.